So, those of you in class who've just done your drawing, here's what you should have got. The 12 coordinates are there. Join them up, they're going to give you a circle. If you had put more coordinates on there, you could have got a more sort of perfect circle, if you like. But it's a circle, no surprise. That was the title of the chapter that we were doing rather. So, we had then, if I'm just going to write down here, this x squared plus y squared equals 9 gave us a circle. Some facts about that circle. Its centre was the origin and its radius was 3. So we can have everybody listening now then, please. Now, where has that 3 come from compared with the equation? Yeah?
The root of 9.
Yeah, that 3 is the root of 9, the square root of the number on the right. So, if I wrote down another equation which was very similar, x squared plus y squared equals 25, yes, that would be a circle. And what would the other things I would write down about that one be then? Go on. Yeah, centre 0, 0, and the radius would be the square root of 25, which is 5. Okay, the radius can't be a negative number, so we're not going to worry about the minus 5 for the square root of 25 as well. Okay, next thing then, moving on. Thinking of the chapter that you have done on transforming graphs as well, what I am going to do next is do a little sketch. I'm going to draw my circle first because my sketch will be better that way. I'm going to put on here a set of axes. I'm going to mark that off as being 2, that as being 8. That's supposed to be the centre of my circle there. And I'm going to mark these 2 extreme points as well. So that is supposed to be a circle. And what I want you to think of first of all is, compared with the circle that we had a minute ago, how do we get from the circle we drew a minute ago to the new circle which I've just sketched here? So how do we get from the one we had to this one here? What has happened? Patrick? I have translated it, yeah. Somebody over here said 5, right. Yeah, the 5 is the centre of the circle. Okay, it's not a perfect drawing. How would that appear as a vector then? 5, 0. Yeah. Now, from what we were doing the other day, what did you do to any function? What did you do particularly to the x in a function if you wanted to translate it 5 right? You actually replaced, I want people to finish it, you replaced the x with what to put it 5 right? Yeah, you replaced the x with x minus 5. That's what we did the other day for this. So that would suggest that because a minute ago we started with x squared plus y squared equals 9. If I replace my x with x minus 5, so that gets squared plus y squared equals 9. So that is the equation of the circle that's at the top of the board at the moment. Okay, that is the same one, but it's been shifted right 5 units. Can I get rid of the drawing bit? Okay. So now I'm going to do another drawing. Similar sort of thing. So that's going to be at 2 and 8 like it was before, and I'm having this at 4 and 10. Okay. So we've got another circle here. 4 and 10 up the side on the y-axis. What's the centre of that circle's coordinates going to be? Yeah, it's going to be bang in the middle of 2 and 6. Average, sorry, 2 and 6, 2 and 8. Average 2 and 8, you get 5. Average 4 and 10, you get 7. So that is going to be at 5, 7. The radius is still 3. How has this circle moved compared with the previous one we did?
So it's a vertical.
Vertical, what translation? Yeah. So from the last circle, so from the previous one, this one has been translated. Now, how can I put this as a vector this time? 0, 3. Yeah, it's gone up 3. Okay. Now, I know that from the work we did with Mr. Wall and we looked at with me last time, normally to move it up 3, what do we do normally to move it up 3? Yeah, add something on at the end. Because this graph...
Well, it's gone up 7. It's gone up 7.
Oh, it's gone up 7. Sorry, thank you. Yeah, gone up 7, thank you. Because this graph, the equation here doesn't start y equals, we don't do that. We're going to do something different. So, if you look though at the equation we had last time, when we shifted it right 5, which is what my finger's pointing at, we've now shifted this one up 7. Is there anybody who either wants to have a guess or just knows what it is anyway? I know you know what it is anyway. Do you know what it is, or are you sort of having an educated guess? Go on then, what do you reckon?
The y squared would be replaced with y plus 7 in brackets and squares.
Minus 7.
Y minus.
Because you're plus in, because it's a plus 7, you want a minus in.
I thought if you come
Yeah,
up, you have
yeah. Callum is actually right here. Okay, yeah. So over here, this bracket here stays the same. The bracket here has a 7 introduced in it. It's squared, just like normal, and it's still a 9 over here. But yeah, the thing here is, when we went right, we used a minus. When you go up, you use a minus. Okay, so it is a bit counterintuitive to start with. Okay, so that is the equation of that one. That one will be a circle where the centre is 5, 7, and the radius is the square root of 9, in other words, 3. So I'm hoping at this point we're probably in a position to look at like a general formula for a circle. And what I'm going to be interested in here is my circle with a centre of AB and a radius of R, what the equation of that circle will be. And I actually would love to hear from somebody who didn't do further maths last year, who can just look at sort of what we've done so far and hazard a guess.
And he's not here.
Sorry?
The only person in this class who didn't do further maths was James Madden, who's and Charlotte.
Oh, apparently there's somebody over there as well.
And Casey.
Okay. So, is anybody, do you want to have a go? When the centre was 5, 7, it was that. When the radius was 3, it was that. Now, all I'm changing then is the 5 has become an A, the 7 has become a B, the radius has become an R. Go on, have a go. Yes, it is. Yes, it is. Yes, it is. Well done. That's right. Okay. So just by comparing basically this one to this one, the 5 has become an A, The 7 has become a B. 3 was the R. That is the general formula for a circle. So if you've got a highlighting pen or anything, what is written down there in red will be really useful to highlight. Okay? The general formula for a circle.
Yep.
So, we'll go through some examples, but they'll start in another video. This one's just hit a 10-minute time.